This is our first video from our new unit from Pythagorean theorem and the number system. Our focus standard for this lesson comes from grade 8, standard G number 9. Know and apply the volume formulas for cylinders, cones, and spheres. Our topic, again coming from our new unit, Pythagorean theorem and the number system, is 3D geometry review using volume formulas. Our essential question for today is, how do the volume formulas for cylinders, cones, and spheres compare? So please take a moment, pausing the video if you need to make sure that you have the focus standard, the topic, and the essential question, along with today's date, copied into your header, that you've set up your question column and your note column, and resume the video when you're ready to begin.
First, I want to start off talking about some vocabulary. Volume is the amount of cubic space inside of a three-dimensional object. And so all of the formulas we're working with today are going to be on volume. Radius is the distance from the center point of a circle. I should also put in here sphere to the edge of the circle / sphere. And that is important to make sure that it is from the center point to the edge. And the diameter is the distance from edge to edge through the center point of a circle or sphere. And lastly, height is the vertical distance of an object at a 90-degree angle to the base of the object. So we will take a closer look at most of these, and particularly volume, radius, and height in the following 3 examples. So that concludes our vocabulary section. So take a moment, again, pausing if you need to get these definitions copied down, and they should be review. So just to refresh our memory. And we're going to start out with cylinders. So here's our cylinder. The generic equation for a lot of volume of three-dimensional objects is capital B times H, where capital B stands for the area of the base. And in this case, the B is standing for the area of the base as a circle. So that formula is pi r squared. So when we put that all together, the volume of the cylinder is pi r squared times height. So over here we have our picture, and I've labeled the 5 centimeters is our radius, the 10 centimeters is our height, and that is technically at a 90-degree angle to the base here, going straight up at a 90-degree angle to the base. So that's what we mean by that in our definition. And so I'm just going to, if you want to take a moment, pausing the video here, see if you can plug these numbers in. So this is also a really good review of substitution method. So we've talked about that a lot in our Algebra Connections book, Substitution of Values. So you're substituting in 5 for the radius and 10 for the height, and then following order of operations. So like I said, you can pause the video here, do your calculations, and then resume the video when you're ready to compare with me. So I'll just take this line by line. I started out by just substituting in my values. So when you do that, I am actually using 3 14/100ths as my pi value approximation, and I will do that throughout. And then we have 5 squared times 10. Following order of operations, we do our squared numbers first. So 5 times 5 is 25. Mentally calculating through this, I know that 25 times, we are now all on multiplication, so order doesn't matter as long as we're multiplying these numbers. And mental calculations, 25 times 10 is an easy 250. Then we can multiply that by 3 14/100ths, and it comes out to being, the volume would be 785 centimeters cubed. So just to point out a few things here, substitution of values is important here, that you show what you're substituting in, that you're following proper order of operations and doing exponents before anything else, that you then have units labeled here, and that your units are cubic, because you're thinking of how many cubes of measurement, in this case centimeter cubes, that would fill this cylinder, and that is 785 cubic centimeters would fill this cylinder. All right, let's move on to, pause the video if you need to copy that down, but we're going to move on to cones. Again, we see the generic formula here of base times height, but it is also divided by 3. The volume of a cone is 1/3 that of a cylinder. You might remember that from our experiments last year, if you were in my class. And the B is again standing for the area of the base. In this case, the base is a circle, so pi r squared. So the whole formula, when put together for finding the volume of a cone, is equal to pi r squared times height, all divided by 3. Looking at our picture here, again, you see that they're taking the height of the cone at a 90-degree angle. That's what that little square is for. A 90-degree angle to the base. So 20 is our height, 12 is our radius. They didn't tell us what this is being measured in, so anytime you're not told, you just say units. Units is a generic word for any measurement that we are taking. So again, pause the video if you'd like to challenge yourself to substitute in these numbers and follow through these calculations. It becomes basically an order of operations problem. So here we go. Here you just see that I'm plugging in the values and continuing to use 3 and 1400ths as my approximation of pi, times 12 squared times 20 all over 3. Doing my exponents first. 12 squared is 144. So at this point then I'm ready to take all 3 of these values in my numerator and multiply them together, which gives me 9,043 and 2/10 divided by 3. And that comes to the volume being 3,014 and 4/10 units cubed. So again, make sure we're following order of operations and labeling our measurements. And volume is always in cubic units. So we're saying that 3,014 and 4/10 cubes would fill this cone entirely. All right, one more. Let's do a refresher on the formula for a sphere. So here we have our sphere. The volume for a sphere is 4/3 pi r cubed. So that is one where people oftentimes make the mistake in remembering the formula. And we're taking a look here. The only measurement we need in order to do this calculation is the radius, which is 9 6/10 meters. For this one, I'm going to round every part to the nearest hundredth, as that's really as far as we need to go really for our purposes. So first, again, feel free to pause the video and substitute in the values, do your own calculations, and then compare with me. Here we go. So just plugging in the values would look like 4/3 times 3 and 1400ths times 9 6/10 cubed. Following order of operations, we need to do our exponents first. 9 6/10 cubes is approximately, rounding to the nearest hundredth, 884 and 74/100ths. Then we take that and multiply it by 3.14. We get approximately 2,778 and 8/100ths. And then we're going to multiply that by 4/3 to come to our final calculation of the volume being approximately equal to 3,704 and 11 meters cubed. So almost 3,704 cubic meters would entirely fill this sphere. So that concludes our refresher on the formulas for calculating the volume of cylinders, cones, and spheres. Feel free to write any questions you may have here in the questions column, and be prepared for these types of problems to start popping up on the warm-ups that we're doing throughout the rest of the year. And feel free to refer back to these notes for the formulas and following these examples of how to lay out and show all the steps to calculating each problem.